Scientists often work with numbers that are either extremely large or extremely small. For example, I've got two numbers written here. The top number you can see is an incredibly large number, and this is actually the number or the average number of molecules of water in a teaspoon of water. Whereas underneath you can see we've got an incredibly small number. Here's the decimal point, an incredibly small number. And this is actually the mass of an atom of uranium. So as you can see, it is very difficult to read or even understand the magnitude of numbers that are this big or small, and it's even more difficult to carry out calculations with them. Therefore, it becomes necessary to express these numbers in scientific notation. Scientific notation is the way that scientists handle very large or very small numbers. In this section, we're going to look at how to convert numbers written in scientific notation into the decimal form. So, let's look at the first question. We're told to express the following values in decimal form, and our first one we need to consider is this one here. This is an example of a number written in scientific notation, and there are two parts to the number. 4.829 is the coefficient, and the 10 to the 4 here is the exponential part of the number. More specifically, the 10 is the base and 4 is the exponent, and it's interpreted as 4.829 multiplied by 10 raised to the power of 4. Or in other words, 4.829 multiplied by 10 by 10 by 10 by 10. And when we work that out, we get the answer as 48,290. And this is the decimal form of the number. We could also think about it. We could also think about working out the decimal form of the number by taking the coefficient in the scientific notation, taking the coefficient and moving the decimal place to the right 4 places. We get this from the exponent in the scientific notation form. The exponent here is a positive 4, which means we need to move the decimal place in the coefficient to the right 4 places. When we do that, 1, 2, 3, 4, we also end up, obviously, with the same answer of 48,290, and this is the decimal form. Before we move on to the next part of the question, let's just note some important points. Now, in scientific notation, we only ever place one and only one digit to the left of the decimal point in the coefficient, and that number is never 0. So for our example here, that's already in scientific notation, we can see in the coefficient that we've got a number 4, the digit is 4 in front of the decimal point, it's not 0, and it's only the digit 4, there's only one digit. So for example, if we had written 48.29 multiplied by 10 to the power of 3, which is the same number, it's just written in a different way, this is actually an incorrect version of the scientific notation. This would be marked wrong because we should only ever have one number in front of the decimal point, and here we've got 2. So this is the only correct form of this number written in scientific notation. Let's look at another example. So here we have another number written in the scientific notation form, 2.91 multiplied by 10 to the negative 5. So our 2.91 is the coefficient, and 10 to the negative 5 is the exponential. Now in the previous example, our exponent was a positive exponent. If you remember, it was 4. And this allowed us to understand that we are dealing with a number greater than 1, and in our case, a relatively large number. Conversely, as is the case here, numbers with a negative exponent are associated with relatively small numbers, numbers less than 1. Now in our case, the exponent is negative 5. This means when we're trying to convert the scientific notation form into the decimal form, we need to move the decimal point in the coefficient to the left 5 places. So I'll just rewrite this underneath so we can see it more clearly. So here's the coefficient. So we'll move that decimal place in the coefficient to the left 5 places. 1, 2, 3, 4, 5. So the decimal point is now here. And when we do this, we get that number, and that's the decimal form of the number. In the previous examples, we were given the number written in scientific notation form, and we were asked to convert it to decimal form. In this part of the question, we're actually going to do the opposite. We've been given two examples with numbers written in decimal form, and now we need to convert those into scientific notation. So let's start with example A here. So the first thing we need to do is work out what our coefficient's going to be. Now remember that in the coefficient we place one and only one digit to the left of the decimal point, and this number is never zero. So in our case, our coefficient would be written as 8.7162. Now, the value of the exponent here must be positive 3, since the decimal place in the coefficient must be moved to the right by 3 places to regenerate the original number. Let's check. 1, 2, 3. Yes, that matches. So let's do this. Go. So combining the coefficient and the exponential part of the number gives us 8.7162 multiplied by 10 to the power of 3. Now if we move on to part B of this question. So again, this is written in the decimal form, and we want to now convert it into scientific notation. Let's firstly work out our coefficient. So our coefficient for this would be 1.837. Now the value of this exponent must be negative 3, since the decimal place in the coefficient must be moved to the left by 3 places to regenerate the original number. So the decimal place is after the 1. Let's check that's the right exponent by moving back to regenerate the original number. 1, 2, 3. Okay, so combining the coefficient and the exponential part of the number gives us 1.837 multiplied by 10 to the negative 3.